Okay, I think now my screen is getting recorded. So I believe most of you know what's the topic in agenda today, and I first of all would like to welcome everyone to this workshop. And this is an workshop conducted by Inceptus and SloopStash. And first, let me start with a simple introduction about our company and what we do and what is Inceptus and all that, what kind of products we are building. And then we'll move on to today's topic. Hope you all know what's the today's topic. So the today's topic is this. So we will be trying to build and deploy a Kafka cluster in the Kubernetes, which is basically a Kubernetes, which is not a managed one, which we'll try to build from scratch using Chef and Terraform, okay, in AWS cloud. I think you all may be having an agenda with your hand in this banner that we have propagated. So most of you may have this thing, and so I'll be trying to follow this agenda now. And my aim is that I want to complete the session by 7:30 today. Generally, when we conduct a session like workshop sessions, usually it goes beyond 4 hours, and people will get lose the patience. So this time we won't be talking more. This time we'll be trying to do some action from the very first half an hour. Okay. So we'll also share the recordings link after this, but it will take some time for us to prepare the recording. But by the end, I think our timeline is that by 6:50 or I think by 7 o'clock. If possible, we can have a question and answer. We'll have a question and answer session, but I'll if we can complete things in another 2 or 2.5 hours, we can have an elaborate question and answer time. So we can close in 3 hours totally. Okay. So first, I'll do this introduction about us, who we are, and what we have been doing, and all that. Now, I'm John, and I I think I'll share my LinkedIn profiles and everything with everyone after some time. Okay, in the group and all that, you can get connected with me. So I first started my career in a small startup, which is called the Binary Workshop, and I completed my engineering degree probably on 2010 August. And after that, I went on to Freshworks, and there I was engaged as a DevOps specialist, and I worked there for 3 years. And hope you all know what is Freshworks and all that. So I was there from 2013 to 2016, and after that I came out, and we started or bootstrapped the SloopStash, which is a technology-based product startup. Now, a background about SloopStash is SloopStash is a by nature, this is a product-based company. Okay, so what kind of products we build is we are specialized in building cloud-based products or softwares to enhance the team productivity and infrastructure security. If you ask me what's the product that you guys have built, we have built a product called Sloop Engine, which is our flagship product. So this is the only product we have built so far. And the main nature of Sloop Engine product is basically like it's an it helps you to build your online software teams with access and auditing on the cloud. Basically, providing the tools required to work online or remote. Okay, so that's the main theme of the product that we have built. So it provides an online browser IDE. It provides you SSH access management, and it provides you logging and auditing, and these are all some of the key features and of Sloop Engine. Okay, and you can have project management like Jira, and we have also been working to provide a complete new revamped release of Sloop Engine, also recognized by AWS Activate
John,
partner program. And
John, there are some people unable to join. John, please wait. I will put on another link. Okay.
okay,
So
I think we are hitting the threshold limit.
Yes, John.
Okay, so we
Please
put the
wait.
other link. Guys, please wait for another couple of minutes because the limit for this meeting is 150. I think we have hit the limit, so other people won't be able to join. We'll put another link there. Satyaraj, I'll open that link on my switch to Inceptors and join. Okay, fine. Sujan, you also have to join. Sujan, you have to also join in the another chat, Sujan. I mean, another meeting.
Okay.
Because I think see people are there. So, Satyaraj or Sujan, so kindly put the message in both the chats. They were saying that we are handling 2 meetings. So, so Sujan and Satyaraj put the message in 2 chats. So we'll be handling. So saying that we are handling 2 meetings now due to the limit, and engage with people because they may be getting frustrated after some time if they don't hear anything. Okay. So here also I have to start my screen sharing, right?
You just do a screenshot, screen sharing, I mean, recording in one Google Meet.
One only I'm recording.
Okay, fine.
Okay, so fine. Now I think in both the meetings I'm presenting, right? So you guys check and let me know in case if something is wrong. Okay. So basically, coming back to where I have left, Sloop Engine is kind of a product which helps the developers to build code and do the development in remote itself. So it's basically a cloud-based product which has SSH access management, project management, and all that. Now these days we've been working with a brand new release or revamped release of Sloop Engine. Basically, like we are trying to what we are trying to do is we are trying to completely build up a new UI and revamp the source code and neatly building something in the microservices based architectures and all that. So that's what we've been doing, and that release will come probably by this month end. So this is the so far story of what we have been doing in SloopStash, and mainly engaging with the product building. And in the weekends, we generally get engaged ourselves with the training programs generally, and workshops are a rare event like this. And training programs we generally do like for DevOps, for cloud like AWS and all that. So we generally teach all these things in the weekends, Saturdays and Sundays in the evening. And apart from that, we also engage ourselves in lots of consulting work to companies generally, but that is not listed in the website. So that's the nature of our company. So primarily it's a product based company, and secondarily we are doing training and consulting, and also these 3 are the things which we have been engaged all through these days. Okay, after I came out of Freshworks. And you can, if you want to know more about our company and the work which we've been involved, you can go to LinkedIn and you can see our company profile and the products that we have built and what we do. So most of the things that we do will be listed as a page, will be provided as a post and all that, so you can see, and you can also follow our company if you want, if you're willing. Okay. And apart from that, I'll also share my LinkedIn profile, because sometimes I'll put that in the chat, so you can. Why this is showing so much things? Basically, let me click my LinkedIn profile, and if you want to connect with me, you can connect with me. So this is my LinkedIn profile. I'll put it in both the chats. Okay. So, and you can check out a few things about our company as well. So if you want to know more about SloopStash also, you can check out this link, which will help you to understand about, I think I'll put our website link. This is our website link. These things, we'll also put that in the WhatsApp group. Maybe I just wanted to sloopstash.com, and you can still see people are joining, so I'm unable to type anything here. Okay, fine. You can, I'll also put SloopStash LinkedIn. You can get it from here, I think. I think here. Okay, so you can check out things later on when you are free, and you can come back to us if you have any questions. So our ultimate aim on this training program particularly is that this is a workshop, it's not a training program, is that we are trying to build a kind of a vibrant learning community. So that's, and to create some awareness in cloud, DevOps, and using the tools like Docker, Kubernetes, and all that, and trying to run different workloads on that. So that's what we've been trying to do all through these days. Okay, so this is our GitHub profile, and this GitHub profile contains the starter kits and the code materials. That is, we do contribute more onto the open source also. So this is also one important thing which we have been continuously doing. So in case if you want to know more about our GitHub repo, which will be useful for your company as well, so because we have built a starter kits for Docker, Kubernetes, Ansible, AWS, Terraform, Kafka, Jenkins, Form, Packer, and so many things, like more than 10 plus starter kits we have been engaging and maintaining in the open source. So people can go and fork it and start using. It will be useful for you. Okay, so in your organization, if you want to do anything with those tools. Now, let me come back to the main story. I'll go to my whiteboard and I'll start with the workshop's agenda. Workshop.
Something like that. Both the meeting edits. It will take.
No, I didn't get that.
So the links and all be posted in some other meeting, I think. Your GitHub profile and your LinkedIn profile.
Yeah.
The link. I don't see it in my chat box.
No, you joined, maybe you might have joined slightly later.
Yeah,
so we try to put all those things. Satyaraj, can you help them? So in case of any questions or something, you guys put a chat message, because I may get distracted sometimes and I miss it. Okay. With Satyaraj and Sujan from our team will help you in chat box. Okay, in case of any queries, you can put that. And how we come to partner with Inceptus is we got a tie-up with Inceptus, and we both have a similar kind of a mindset. So we both try to bring some new things in the table to the people in the industry. So that's, but this workshop is also one initiative that we have taken. So Inceptus has been we've been partnering with Inceptus for more than 4 years now. I think more than 4 years, and more than 3.5 years or 4 years. And so far we have trained almost 300, 400 plus candidates only for DevOps, and including AWS, we might have crossed 500 candidates or someone like that. So around that mark. So that's what we've been doing with Inceptus. So apart from that, I think I have explained enough about myself, and that's why I've given the LinkedIn profile. I can't talk about more about myself and the company and all that, because we have a less amount of time to do something. Now let me start with my whiteboarding, and so I require everyone's attention for next 45 minutes or something, so I can show something, and maybe you also can benefit, and we also will be able to share something better for you. Now I'll share so we have prepared the workout for today's topic, that is building Kafka cluster on Kubernetes in cloud, AWS cloud. So we have prepared all the things. We'll be sharing this after the workshop is done. Okay, and we'll also be sharing this in the SloopStash blog. For example, last time when we did a workshop on Hadoop build up on Kubernetes, we actually gave that. So those links are there. You can also find it in SloopStash blog. I'll also share this as a separate PDF in the WhatsApp group. Okay, after the session is done. Now let me start with my thing. So first we'll start with a simple introduction about DevOps. Okay, generally this is one of the $1 million questions that people go to the internet and learn so many things. We'll try to share a simple and neat thing which you can understand. Any layman can understand that. Okay, so first it is understanding about DevOps. Okay, now let me put it like this: understanding DevOps. To understand DevOps, what we have done is in SloopStash we have formulated something called as it's a kind of a small theory that we have formulated. It is called as the wall diagram theory. Okay, it's called as the wall diagram theory. So the main motive of this theory is basically to help people understand. I mean, if I tell what is DevOps based on my work experience, and if I keep on talking about things and we did that CI/CD pipelining and all that and all is not really what it is. It is something which is a concept oriented thing that we have to understand first, and before talking about it too technically, because generally when people talk about DevOps, they say it's a CI/CD pipeline, or they say Docker, tools, containers, and you see, it is all just the technical implementation, and it's all just technical implementations. We can't understand DevOps like that. So that's why we formulated this wall diagram theory. So what we generally do, I'll try to share one more Google Keeps whiteboarding. I think in the SloopStash blog, there is one blog post called Demystifying DevOps Profession, the wall diagram theory. We'll share all those links. Maybe you don't have to run here and there. We'll collectively share everything. In this wall diagram theory, you should be able to see some kind of a brick wall layout and neatly understanding what DevOps is all about. You can watch that YouTube video when you have some time, but I'll very simply give the explanation for that. In the wall diagram, see, generally when you talk about a brick wall, okay, so what we do is we try to compare a brick wall with an organization. Okay, so when you talk about a wall, okay, a brick wall, when I say a brick wall, that brick wall is basically like, okay, let me take this one, and I think we have one picture here, one illustration which I've done for this previous batch people. I think we'll reuse that instead of again writing. It's holding for a long time. So this is generally this whiteboarding I did for my previous batch people 9 months back when we started our DevOps batch. In that, I try to again restructure that full wall diagram theory approach to understand DevOps. You see here, we need to treat, if you take a brick wall, generally when you go there outside, you will be able to see lots of building material, flats being built and lots of things happening. In that, if you have seen a brick wall, the brick wall is something which is a very integral part of an premise. Okay, and I'm going to compare the brick wall with an organization components. Generally, organization means the teams, what are all the teams available and all that. So that's why what we do is the wall that we see here, the overall wall, we generally compare it with the total organization. Okay, the complete organization is compared to the wall, and the bricks that is in the wall. If you see in this picture, you will be able to fairly see this is the wall and these are all the bricks. The bricks that you have in the wall is generally considered as team. Okay, teams means you in a company you have you may have a software development team. In a company, you may have a software delivery team, infra-ops team, quality analysis team, big data team, machine learning team, monitoring team, performance. So you will end up with, obviously, you will end up with lots of teams in a organization. So, and when you say an organization, generally, it means a collection of a bunch of teams. Okay. So what we compare in this wall diagram theory, it's a kind of a beautiful understanding, but I need more time to explain it very accurately and with so many examples. But because this opening session, generally we do it for 4 hours. So only understanding what is DevOps. So I can't take that much amount of time now because I'll make my notes very simple and short. So you can compare this whole wall with an organization, and you can compare the teams in your organization like big data team or NOC team and everything like bricks. Okay, so it's a simple comparison. When you compare the wall with this thing, and you can compare the bricks with the teams available in the organization, not team, it is multiple teams, and then you can so teams means you have a software development team, all the other teams. Now, what we can compare this DevOps job role is basically like DevOps job role is a kind of a cement, or you can call it like a glue or a cement, which actually runs through. See, when you see a brick wall, in that analogy, you see the cement runs throughout the wall. If you can see, if you open and see that the cement runs throughout the wall, the main purpose of the cement is to integrate all the bricks together and try to hold everything together. You get the point, right? I do have very little time, but I'll try to make the point very clear. Please listen carefully. When you look at a wall, you see the main purpose of a cement in the wall is to run through the wall and glue all the bricks together and bring a strong bonding, and you can call it like an integration. Okay, can call it like an integration. Now, when you want to understand the DevOps role or DevOps job role, actually speaking, only based on my experience and what we have done in Freshworks, and because in my area, when I was getting recruited in Freshworks it is around 2013. Okay, so we were doing lots of self-exploration in that time, and we were a small team. We learned things by doing, and it was all 9 years back. And I even resigned the company some 5 years back. So it's all, I'm talking, when I say this approach, this is something which is totally from the experience, and this is how we came to understand how a DevOps engineer has to work out. In the internet, you may find lots of explanations, like it's like bridging the gap and that and all. I don't know what about all these things, but in my opinion, it's a kind of a gluing role. You have to plug and play with different teams. It's not so that's why we generally call DevOps as a multi-skill oriented job role. It is not about a single skill. It's something like a multi-skill oriented job role. So you have to have multiple skills like cloud engineering, handling the tools like Docker, Kubernetes, learning some scriptings. Also, that is important. And I'm just trying to give the overview or picture. So here you can compare a DevOps team in an organization to the cement. Okay, so if you can get this analogy right in your mind, you will be able to understand what is the wall diagram theory. So basically, the cement, or you can call it like a glue, which is basically the DevOps team. That if you are going to a company, or generally when you go to a company like Freshworks or Zoho or good product companies, or any better good companies which has lots of things to do, and you will be able to see this analogy coming into work. Okay, so whenever if you trigger out, if in the internet, if you go there and find something maybe contradicting to what I am saying, you can check all these things and you can take whatever you want. We are not saying this is how it should be. I'm saying things through my 9-year-old experience in this, okay, and still we've been building products and doing so many things. So that's why we were able to accurately say it is a kind of a gluing role. So you have to plug and play with the different teams. When you say a DevOps role means you have to plug and play with the different teams, basically running throughout the wall or running throughout the organization and integrating and coordinating everyone. Okay, so that's the kind of role, and it's a challenging role but an interesting role also. So that's why we generally say the DevOps role is basically an integral part of your organization. So it is something that you have to plug and play with other teams. Generally, people ask me how many teams I have to sit and plug and play. 2 or 3. In this picture, I have given lots of other teams. Generally, it won't be like that. You have maybe working with 2 or 3 other different teams for some purpose. That's all. So you won't be working with all the teams. Sometimes in growing companies, you will be able to get that opportunity to plug and play with the different teams. But in generally, you will be getting around 2 or 3 teams or 4 teams to the maximum. Okay, so whenever if anyone asks, if you think about DevOps, always try to bring this picture in your mind. Okay, that is also that is also available in the video and the blog and all that. You can read through that. Okay, so never try to get faked by something which is in the internet, because the internet generally proposes lots of misleading information. You have to know what is what, and we say something, you don't have to believe what we say, but you try to take the point and compare it with other things and know what is best thing for you. Okay, so this is the small introduction about DevOps. I don't say this is an elaborate introduction. Actually, I don't have an time to do that. We have to get into our topic today. So this wall diagram theory of this understanding of the wall diagram theory will be very useful for you in understanding what is DevOps. So the simple comparison is this: you just compare your wall with the organization, and you compare the bricks with the team, and then you compare the cement or glue with the DevOps team. That's all. So if you can get this thing, you know what DevOps role is going to do. Okay, so this is the fact and this is the truth. Okay, so now I think I've made my point straight and clear, so I'm not going to talk more about this. Now we'll go into some of we'll now try to understand the workshop's agenda now. So we said that we'll be trying to build this Kafka cluster in Kubernetes, and this is the workout that I'm going to try and demonstrate now. Maybe I think I may take another 1 hour, or I don't know. We need at least 2.5 hours or 3 hours to do something with this. Okay, so because it has lots of segments, so I'll start one by one. Okay, so first step, what I'm going to do is I'm going to start with the architectural understanding. Now, you may be from a non-DevOps background, that is totally fine. So this workshop's intention is for people who haven't been from the DevOps background or from cloud background. Okay, so this is just to create an awareness and kind of an interest on these kinds of topics. So what you can do with these tools, and that's the main purpose of this session. Okay, so you don't have to know what I'm technically doing is perfect, or you don't have to worry about that, but you have to worry about understanding the architecture and how we use these tools. That part you have to, you may not need to know the commands, how to build the Docker image or how we run the build the Terraform configuration. You don't need to know that, but you can watch it, but you need to understand what architecture we are trying to do. Okay, now we'll get into that. I'll try to take another probably around half an hour or 20 minutes to completely explain this architecture to you, so that you can, when leaving this workshop, you can go with something on your head. Okay, so
John, sorry to disturb you. Like, are we going to do anything like a cluster creation in this session?
Yes,
Are you going to explain anything like that?
we
Like
are
how
going
to?
to do that. You see,
Yeah. Okay, okay, fine.
first in this, now I am in the third point now. Okay, after that only these things will come. So architecting Kafka cluster. Okay, architecting a Kafka cluster and on AWS cloud. So now this architectural understanding is a very important thing for us before we go and build things out here. Okay, using tools like the Docker and the Kubernetes and Terraform and Chef. Okay, so these are all mostly familiar tools. Most of you may have learned this in some other places, or you may be using this in your company. So we are just trying to come here and solve a different use case. Okay, so we are not masters of Kafka, but when we came up, we have a need for that in our organization. And whenever we try to bring something, we try to propose a workshop or free session like this. Now listen carefully. First step is that we need to know what these things are and how these things are going to play together. You can see here we have said that we use these tools and all that. We need to know how these things play together to accomplish the given the workload on the cloud. Okay. Now first, whatever you wanted to run, whether you wanted to run a Kafka cluster, whether you wanted to run Hadoop cluster, or you wanted to run an Elasticsearch cluster or MongoDB cluster, whatever it is, you need to first build the infrastructure. Okay, generally we have a saying in SloopStash that generally in our DevOps session we talk about a topic called infrastructure management. Okay, it is a very important topic. So infrastructure management. Every DevOps engineer has to ponder around this thing. For when DevOps or cloud means you have to know how to manage the infrastructure, because most of the components you deal is based on infrastructure. So in the infrastructure management, there are 3 golden steps that is available. Okay, the first step is capacity planning. Okay, I think I have spoken about this numerous times in my DevOps sessions and in cloud sessions generally. So people, if they are attending from if people from our batches, they know all these stories very well. So capacity planning and infrastructure provisioning, and then deployment. Now you see, these are all the very important 3 steps or 3 phases of your infrastructure management. So it starts from a sequence 1, 2, and 3. Okay, so we are not going to do capacity planning now. That is a kind of an mathematical idea that we have to do. So I'll show. I'll show how. I'll show what is capacity planning. Generally, it is to compute and derive some numbers. Okay, so it's something which is not needed now. Capacity planning. It is something which helps you to compute the numbers. Okay, so these are all very lengthy topics, but we are not going to do this now. So what capacity do you need? So that's why we do the capacity planning first. And then once you compute the numbers or capacity required, then you will start provisioning the capacity. Now, when you start provisioning here, we need to say what tools we are going to use here. This is the place where we use Terraform. Okay, this is the place where we use Terraform. We use Terraform to build the infrastructure components. Okay, we use Terraform to build the infrastructure components that is needed for running our workload. What is our workload here? Our workload here is Kafka. Okay, our workload that we have planned to run is Kafka. Okay, and we are going to use Terraform to build this infrastructure components required to run the Kafka cluster. Okay, and then after building the supporting infrastructure, we are going to deploy Kubernetes. Okay, for that we are going to use Chef to deploy a Kubernetes cluster. Okay, we are going to use Chef to deploy a Kubernetes cluster. Okay, Chef is basically an you may know that it is an in configuration management tool, I think so. In our DevOps session, generally we don't give this name. This is a slightly outdated name. We call it as a kind of a deployment engine. Okay, Chef is a deployment engine which we use to automate the deployment in our machines, whether it is a container or a server or a VM or whatever it is. So you can also call Chef as a configuration management tool, but that's a slightly outdated outdated definition for that. So here the tools that we use, that is the Terraform, which is to build the infrastructure components, and we use Chef, which is a deployment engine and or a configuration management system. And using Chef, we are going to build the Kubernetes cluster. Okay, using Chef, we are going to build the Kubernetes cluster. Now you can ask me, where does Kafka is going to run? Now Kafka is going to be provisioned within the Kubernetes cluster. Within the Kubernetes cluster, we are going to build a Kafka cluster, because we are going to run Kafka cluster as a containerized workload. Okay, so we are going to run our workload within the Kubernetes cluster. So for building and deploying the Kubernetes cluster nodes, we use Chef. Okay, so this is the chain that we are going to accomplish now. Now, I'll try to illustrate things in a pictorial way. Generally, I do it like that, so which people can take something out of it. You may not understand the things which I am trying to execute technically. That's totally fine, but you should be able to understand what I'm speaking now. Okay. Now, I'll give a small illustration here. For example, I'll start with this. So, using the Terraform. First, using the Terraform, what we are going to do is we use the Terraform providers to plug with the AWS cloud. Okay, we're going to plug with the AWS cloud. And what Terraform is going to plug and play is Terraform is going to create resources in the AWS cloud. Basically, resources like, supporting infrastructure resources like VPC resources, IAM resources, EC2 resources, EC2 NAT servers, and every other supporting resources that is required. Okay, so when we run the Terraform execution on the first hand, this is going to be the first step that we will be doing today now after this explanation of the architecture. So Terraform will be creating resources in AWS services like IAM and S3 and VPC and the EC2 and OpsWorks. So we'll end up with the creation of so many AWS cloud resources. Okay, so for that we are going to use Terraform here. Okay, for that we are going to use Terraform to do the building of infrastructure. So what we are going to do is we are going to build the AWS cloud infrastructure. I'll write it very elaborately. We're going to build the AWS cloud infrastructure required to run Kubernetes platform. Okay, so to run the Kubernetes cluster platform, you have to build the supporting components here. See, in IAM we have to create small resources. In maybe in the VPC you have to create lots of resources. So I'll just try to use some different colors. In IAM you have to use something, and in VPC S3 you have to do something. VPC you have to create resources. So everywhere you have to create the supporting infrastructure resources in order to build this infrastructure, cloud infrastructure required for running the Kubernetes cluster. Okay, so only when you have the Kubernetes cluster built and deployed, then only you will be able to run your Kafka cluster on top of that. Okay, so that's the layering that we are trying to do here. Now we So now we'll first try to build this one. And after completing this, the second step is going to be, we will be trying to, once this infrastructure is built, we'll be using Chef here. Okay, what Chef is going to do is, Chef is going to play with a service in AWS called OpsWorks, which is a very less used service, but it's a very, very, very powerful service. We use AWS OpsWorks for deploying our Sloop engine services and all that. So it's one of the favorite services for us. So AWS OpsWorks is a managed Chef service, which helps you to manage the EC2 instances. Okay, EC2 instances neatly and in an organized way. Okay, so it helps you to manage, and I can say you can perform deployments on your EC2 instances. EC2 is an hypervisor which provides you the VMs or servers in simple words. Okay. So you can have your EC2 instances. In EC2 instances, we will be trying to build a Kubernetes cluster. So let's say we need to, what Chef is going to do here is Chef will be trying to do these things. It will try to install Docker tools. It will try to install and configure, I think with using this word I'll use, it will deploy Docker, it will deploy Kubernetes, things, and it will configure the Kubernetes, and it will also make sure it will help you to form the clusters. So cluster formation, all those things will be done from Chef. So that's the primary use of Chef here. So using Chef in the AWS OpsWorks service, it's a managed Chef service. We will be deploying tools like Docker, Kubernetes, and whatever tools that is required for formation of the Kubernetes cluster. So what ultimately after the Chef deployment, what you can expect to see in the EC2 instances, it will work like it will be able to form a Kubernetes cluster, okay, on top of EC2. So that's what we'll be trying here. So we'll be trying to build a Kubernetes cluster using the set of EC2 machines, and that happens with the help of Chef tool. Okay. So in the AWS OpsWorks service. So that's what we are going to do. That's the second step that we'll be doing here. So as I said, in the infrastructure management, you see capacity planning, provisioning, and deployment. We use Terraform to provision the cloud infrastructure required for Kubernetes platform, and then we use Chef to do the cluster formation and deployment of the Kubernetes nodes and Docker services, and there are other things also, Containerd. So Containerd also is there. So that is also one, another tool here. Okay, Containerd. Okay, so these are all the things that we'll be doing here. After doing this, once you get your desired services up and running within the nodes or whatever you call as EC2 instances, then what we'll be trying to do is we'll be trying to use Kubernetes here. Okay, that's the third layer. We will use Kubernetes. Okay, I will go here. We'll use Kubernetes API objects. In Kubernetes, whatever workloads that we are going to run as containers, we need to say it as API or objects in Kubernetes. Okay, so what we'll be doing is we'll be trying to provision Kubernetes resources or objects in Kubernetes. What kind of objects we really provision here in the Kubernetes is basically like to run Kafka cluster, we use an object called stateful set. Okay, we use an object called stateful set, which helps you to run the Kubernetes pods. The pod is a very core unit of Kubernetes, but stateful set is the higher level abstraction which we use to provision pods with certain set of configuration. Okay, so we'll be running the Kafka nodes as Kubernetes pods, but we'll use the primary thing as stateful set. Okay, so using stateful set only, we'll be able to provision the Kubernetes pod, not directly running pod. There are reasons for that, but again, I don't want to get into the more technical story. My intention here is that everyone has to take something in the mind once you leave this session. Okay. The workout will be provided in the WhatsApp, so you don't have to worry about it. Now, what we'll be trying to do across the Kubernetes nodes, that is, in fact, the EC2 instances, we'll be trying to launch a tiny 3-node cluster in Kubernetes. We can't build a 5-node or 10-node. We can do it, but everything is the same process. So these are all basically the Kubernetes nodes. Okay, in your Kubernetes nodes, worker nodes, generally, the workload called Kafka will run. So let's say this is the color. I'll choose a different color for it. This one. So you can see the Kafka nodes will run distributed across the Kubernetes nodes. And that is because of stateful set. We use the stateful set. And you can ask me, in Chef, in OpsWorks, when you try to build EC2 instances and try to deploy a Kubernetes cluster, how will you do that? So maybe I think I didn't explain that. We use something called as Chef cookbooks here. Okay, it's called as Chef cookbooks. In Ansible, I think you might have heard a word called playbook, but in Chef, it is called as cookbook. Okay, so it's written on Ruby. Ruby-based cookbooks. So we'll be using that to build this. Okay, Kubernetes cluster and cluster formation, etc. And when you go to Terraform, I think I also have to say to build this infrastructure required for the Kubernetes cluster. What we have to do, what we have to do is we have to write something called as Terraform configuration. Okay, it's called as Terraform configuration. Terraform is a tool which is an open source tool from a company called HashiCorp, which is one of the famous open source companies. They have built tools like Vagrant, Packer, and Terraform, Console. All these things are their tools. We use almost most of their tools that we in Sloop Engine and in our company SloopStash. Okay, so you see this building this infrastructure means we use something called as Terraform configuration, or we can say it like just configuration, and some modules that we have built to perform this operation. Okay, so using the Terraform configuration, we will be able to build this infrastructure, and using the Chef cookbooks, we will be able to build the infrastructure required for Kubernetes cluster. Using the stateful sets and other Kubernetes resources, we will be able to run the Kafka cluster on top of it. Okay, this is the Kubernetes cluster. Within that, we'll be able to run the Kafka cluster here. So this is how we are going to do things. Okay, there are lots of technical explanations that has to be done. See, this is a very small time, and the given time for me this time is just 2.5 hours. Okay, so I have to be with at least by 2.5 hours. I should be able to complete the hands-on at least. Okay, then after that there will be a lengthy QA session that people will raise lots of questions on that, so I should be able to answer that. So it may cross, that itself will cross around 3 hours or something. So I have to do certain things really quick. Okay, now I believe most of you might have understood what I am trying to do. Okay, so now I'll put a full stop here. How many of you are able to understand what I told very clearly? Please put yes or no in the chat. Okay, please put yes or no. In case if you have any questions, you can, don't take more time. So another 5 to 10 minutes, so you can ask few questions related to this. Okay. So very simple infrastructure management in that 3 steps. We are primarily doing the second and third step repeatedly, and I said what are all the tools involved in that. And I'm step by step I'm showing. First, we'll use Terraform to build the cloud infrastructure for Kubernetes required for that, and we use Terraform configuration to do that. So that's the main important thing here. Using a Terraform configuration, we'll be able to build the resources on AWS cloud. The resources that we build generally are from services in IAM, S3, VPC, EC2 Ops. So it's all the resources, and then we go to Chef. In Chef, we use Chef cookbooks to build the Kubernetes cluster. So that's the aim that we have that's what we're going to do there. And that's going to happen on top of EC2 instances where we'll be deploying Docker, Containerd, Kubernetes, and the cluster formation and all that. And then we go to Kubernetes, where we'll be trying to use stateful sets and pods to provision our resources or objects that is required to build a Kafka cluster on top of Kubernetes, which is a container cluster now. Okay, so this is how we are going to proceed. Okay,
so then what is the use of this Kafka cluster?
Kafka is a data streaming platform. Okay, I think I didn't talk about Kafka.
Yes.
Sorry. So because that's a workload, I didn't talk about it. Now, Kafka is a kind of an, I'll write it here. So Kafka is a streaming platform. Basically, like you can process, you can build your data pipelines, you can build your pub/sub models, you can use it for messaging systems, streaming, data streaming, and building the pipelines and pub/sub implementations.
Is it like Jenkins?
No, Jenkins is a CA engine. Kafka is a data-oriented engine. Jenkins is a CA engine. Okay, yes. Kafka is a data-oriented streaming engine. Okay, so what you can do with Kafka is you can process the data and you can send it to multiple receivers. So maybe, I don't know, there is something called as a pub/sub messaging system. So you have some kind of simple use case. You create a topic called, let's say, Nginx log. Nginx is a web server, so you create a log called Nginx, and you try to forward the log to this topic called Nginx, and that will be supplied to the subscribers of that particular topic. So the topic is something which is a major component, and then the subscribers will be able to read that. Okay, so it's a kind of an data pipeline streaming pub/sub mechanism. So we can use Kafka for most of these use cases, like log management also. Log streaming also, people use that. So this is one of the simple explanations which I can provide. But when we wanted to explore more with that, there are so many other use cases. You can use Kafka to stream data from one database source and pump it to another database source. You can use it like an ETL. Like an ETL mechanism, yes. Also. So there are so many use cases with that. Okay, so that is what.
Yeah, got it. Thank you.
Now, in this workshop, we are actually not going to get into the Kafka story completely. We are going to show how we are going to build the Kafka cluster, but the usage of the Kafka cluster and how things based on that we can have probably in another workshop, or again we need to have some. It looks like a kind of a big data workshop or something like that. Maybe it will tilt our focus from this thing. So that's why. Okay, maybe however we'll show some small workouts creating some topics and all that, but that's what we have planned here. And in the Kafka, what we'll be trying to do is we'll be trying to build the brokers and controller cluster. Okay, so generally when you go to Kafka, it's basically a Zookeeper based cluster. So in the recent versions, I think last 2021 they were releasing some quorum controller based cluster. So we'll be running some of the nodes that I'll try to distinguish it with some color codes. We'll be running the Kafka controller nodes. I will use this color called, what color? I'll use this color. let's say this is all the controllers. I mean, it will run in different nodes, and then we'll have the brokers there out there. So we can put this color, the brokers and the controllers. Okay, so you can run things like this. Okay, so brokers and controllers. These are the two main services in the Kafka which we are trying to run today. Okay, so two services. One is the Kafka controllers and the controller nodes, and then we'll be trying to run Kafka broker nodes. So these are the things that we are going to run. Basically, we'll expose these two things as Kubernetes service. Actually, it is another component in Kubernetes which helps you to expose a specific what you call as an endpoint as a service, or what you call as a service you can expose as a real service in Kubernetes. So that's another abstraction for these things. Okay, so I'll explain when we go there. Slowly, when you see it, you will be able to understand what I'm saying. But now the picture is very simple. So we'll try to start we'll try to do one by one. I think we need another 1 hour to see things, how things are working. We have tested the workout previously, and we'll see how this is going to span out. Okay. Any questions with this before I start with my hands on? Okay. In case of no questions, we'll now get with the workout. So the first step is building the infrastructure. Okay. First step is to build the AWS cloud infrastructure for Kubernetes. Now we'll first start with that. You can see that, I mean, whatever we are trying to work out here, everything is available and made available as open source. So as I said, we involve ourselves more in open source community contribution. There is an initiative called Giving Back to the Community. So you can find whatever that you want will be available in your in the GitHub. You can, when I share this book document, you should be able to do it by yourself, or we'll be publishing it as a blog soon. So you can also take the workout. Okay. Now, first, we will download our Kubernetes starter kit from the GitHub repository. Okay, so this is a Kubernetes starter kit repository, which we've been maintaining for years now. And first, all the things that the chef cookbooks, the Terraform configuration, everything is now available in this repository. So first, I need to take it out. Then only I'll be able to build what I'm supposed to build. Okay, so now I'll first start with this. I'm going to first download my starter kit. So let me clear my screen, and I'm going to first download my starter kit. This is a simple bash terminal. Hope most of you know that. Maybe people who are not from the Linux background, this is a Linux machine. What I'm trying to execute is a Linux machine. Generally, there is a question that people ask. I'll also answer that. Whenever we deal with the DevOps, I mean, particularly with open source technologies, say for a Terraform or a Chef or a Kubernetes or Ansible or see, open source technologies are built for open source kernel. Linux is an open source kernel. If you can check out Docker, the Kubernetes, whatever you see, all these things are built specific for the open source kernel. Okay, so that's why Linux kernels, whatever Linux kernels that you have will provide out of the box support for all these tools. But if you go to Windows realm, you can't expect that support because things are not built for Windows. Okay, it's a closed operating system. We have to understand all these things. So when you deal with open source technologies are built for Linux kernel, open source kernel. Okay, so sometimes people ask a question whether I can use build a Chef Automate server on, for example, in Windows. That is not possible. Okay, Chef Automate server won't run on Windows. I can, even if you see the documentation which we provided, it does not run on Windows. That is one of the key points here. Even if you go to Kubernetes, you won't be able to run the Kubernetes on, certain control plane components and their plugins and extensions on a Windows machine, because it is built for Linux machines. So that is why every time when you try to build these open source components, even Docker doesn't have a direct integration with Windows. So they have some kind of a small hyperkit, some kind of an VM based micro VM or something to couple it with the Windows system. So there are so many difficulties. Whatever open source tools that you deal with, none of it is designed for Windows. Everything is designed for open source kernel, which is the Linux kernel. Okay, so that's why when you go to DevOps kind of work role, generally you will be into Linux more. You need to know the depths of Linux, at least good understanding of Linux systems to do something with that. Okay. Now, so I have cloned my Kubernetes starter kit here, and now I'm going to go into my this one. I'm going to change the ownership, so now to make it work. So then now first step is I'm going to build the infrastructure on AWS, which I said here, that is to run the for supporting components for Kubernetes. So for that, first I need to install the tool called Terraform. See, Terraform installation is it's a simple program that you can download and install it in your system. It is a simple binary executable program. You don't have to, it is not a kind of even a big package or something. It's a simple binary program that you can download. So now I'll try to download Terraform here. Okay, so I'm trying to download Terraform 1.0.1. Okay, which is I think the latest one is 1.20 to 1.2.8. We use the Terraform 1.0.1 in our production, so we stick with that version. Now I'll unzip it. Okay, I'm unzipping it. So it will produce a simple binary program called Terraform. That's the executable binary. In Windows, you say that exe, right? So in Linux, it's all binary executable. So you just get a binary executable or a bin program. You can call it like that. It's a program. Now, people say it is command, but general technical definition, it's a program. Now you can install Terraform. Installing Terraform is just to move the Terraform program into the user local bin path. So we'll just move it now to the user local bin path. So it will be accessible as a command. And then check the Terraform version. So you can check and see here. So this is how you will find an output. So we have installed Terraform 1.0.1, which is something which got released last year, and I think in August or last August or October. It's just 1 year old. Now you have the latest version as 1.2.8. 1.2.8 we haven't so far tested in our productions anywhere in Sloop Engine or in our products. So we stuck with this 1.0.1. Okay, so this is how we installed Terraform. And after installing Terraform, what we have to do is we need to now start provisioning the AWS required using AWS resources. I said this, right? This point. We are going to create resources in IAM, S3, VPC, EC2, OpsWorks. So we'll be creating, I think, another 30 or 32 resources. I don't know. So all these resources are created using this. I'll show this. This is how, once you download the Kubernetes starter kit, you will be able to see this here. This is all the meeting links. For now, I don't know, let it be there. This is how the Terraform configuration looks. So you can see everything is written as infrastructure as code. You might have heard a word called infrastructure as code. In the internet, you might have heard about if you go to DevOps related things or things. So IAC, which is called as infrastructure as code. So infrastructure as code is what a Terraform configuration is all about. Okay, so you can see we have built an AWS module for Terraform, and we have crafted all the resources that is required. You can see it here. Okay, so almost we are creating resources on IAM, VPC, and we'll be creating route tables, and you'll be able to see around, I think, a 500 line of them. It's a very small one, okay, small one, and we'll create some OpsWorks template. We'll boot some NAT servers, and so many other things will happen here. Buckets, 3 buckets, and security groups in VPC. So we'll be playing around with 4 or 5 AWS core services to construct this infrastructure. Okay. Now I don't have the time to explain what is the VPC. It's a networking component in AWS. IS3, you know, it's a bucket, and storage, and IAM is an access control stuff, and EC2 is a computing thing and service, and OpsWorks is a management, chef managed service. So that's my simple definition. But again, all these things has its own way of, we have to spend more time to understand it. Now we'll get into the topic now. So here, first I'm going to, what I'm going to do is I'm going to execute this Terraform configuration. This is the Terraform configuration, which we have made it like a modularized. We follow the modularized approach, which is the best practice. So it's a module. Okay, so we're going to run this Terraform configuration, and we're going to see what's going to happen. It's the reality infrastructure. See, when you deal with Terraform, generally, I'll just try to reuse some of my old whiteboards, which I did very recently. When you deal with the Terraform, Terraform is basically kind of an, we need to say it's a hybrid cloud modeling engine, okay, where you can go plug and play with the different cloud service providers in a single run. Okay, you can go plug and play. Basically, if you want to build infrastructure across multiple cloud service providers like AWS, GCP, Azure in a single stunt, you should be able to do that with Terraform. And that's how our Sloop Engine's architecture, product architecture is powered up with. So we use Terraform to do something like that. Okay, now if you see, whenever we deal with the Terraform, maybe this is a whiteboard, you may not get everything, but focus on my cursor so you don't have to read everything to get confused. You see here, when you supply this infrastructure as code, it will be able to create something called as a reality infrastructure. Whatever you see in this format, this infrastructure as code format, this is basically called as a logical infrastructure representation. But when you run this logical infrastructure representation, which is written as an infrastructure code, you will be able to create a reality infrastructure, whether it is in AWS or Azure or GCP, you will be able to do that. So that's the resources that you will be able to create. So the reality infrastructure is something which you create and build the components, and the logical infrastructure is what we call as an infrastructure as code. You get the point, right? And this is the infrastructure as code. And in Terraform, this is called as Terraform configuration. Okay, so I think I'm making my points. If you want, I can share these things in the WhatsApp group after this. Now let's go there and we'll do the execution part. Now we are going to build that infrastructure. So let me go to the Terraform directory. So Terraform directory is within this place. So I have to go to cd opt start Kubernetes path, and I'll go here. Okay, so clearing the screen. Now I am into the Terraform directory. So here you can see the Terraform module, what I showed in my Sublime editor. That's what you are seeing here. All the things required, infrastructure as code stuff is here. Now I'm going to go and execute, create one SSH key pair. The reason why I create this SSH key pair is because you should be able to go and SSH to this EC2 instances in order to work out the cluster and debug or troubleshoot, and so you should be able to SSH to this. So you need to create an SSH key pair. So that's what I'm trying to create here. Okay, so now let me execute this one. So it will create EC2. Sorry, it will create an SSH key pair with the private and public key, which is used for authentication purpose and login to the EC2 instances. Okay, so that's why we created. When I share the whitebook, when I share this this document, you find the comments on top of it, so you can understand and work out when you are working out. Now, in Terraform, you see it has a very simple, three-step process. So you have to first do something called as initialization. Okay, you have to do something called as initialization, and then you have to do something called as plan and apply. Okay, so initialization is first, then you need to generate something called as a plan, which is a blueprint, and then you're going to apply it. Okay, apply the plan. So this is the three-step process in Terraform, where the initialization is always a single time process. But when you go to when you generate a plan and apply a plan, it's a repetitive process. The process 2 and 3, it's a repetitive or a frequent process. Okay, so what we are going to do here is this process. So we are going to do this initialization once, and we can go on creating the plan again applying and all that. So it's an frequent process. So this is what we're going to do. The plan is generally called as the blueprint, and the application of the blueprint is generally called as the Terraform plan is generally called as the execution of the blueprint. Okay, now let's go and try that. So we're going to do the initialization. So I'm going to do this Terraform init now. So I think I can do it here. So this is the place where we have the configuration. So you should be within that, do it. So now when I say Terraform init, you can see that output. I don't have more time to interpret the outputs, but you can see that Terraform initialization is done with the installation of the provider plugins like AWS, and configuration of the backend is done. Everything is done now. Now our module, AWS module, is also properly initialized. So once that is done, we need to create something called as a Terraform workspace. So Terraform workspace helps you to I'll show that here. A Terraform workspace helps you to isolate the resources based on a simplistic namespacing. So what we are trying to do here is to create, and see, in your company, you may have a production staging, a QA1, a QA2, a pre-staging, so many infrastructures to be built. So you can namespace things, yet you can use a single Terraform module or a single configuration and reuse that. Okay, and create the resources in the reality infrastructure by just doing some simple namespacing on that. Now that's the picture here. So that's why we're going to create something called a workspace, so called prod. Okay, which is generally nothing but an environment. Okay, so prod. We can create QA1, staging 2, or prod 2, whatever you want. So it's just a namespacing the resources. Okay, now once this thing is done, I'm going to now load some configurations, and then I'm going to create a plan, generate a plan. So this is the Terraform plan command, which will end up in generating a TF plan template. It will be written in a kind of an binary compressed format, so you won't be able to read what it is trying to write, but I'm supplying the proper variables, and I'm trying to supply the plan, output file. This is the place where it will write the plan. Okay, now let me copy this command and let me apply this, clear my screen, and I will apply this. So it will ask you for a bucket prefix. Bucket prefix is, see, in S3, when you go to Amazon S3, the important thing about S3 is that S3's bucket namespacing is a global one. Okay, S3 bucket namespacing is a global one. So you can't go and you can go and try to create a bucket with the same name. If I create a bucket name called SloopStash, you can't create the same bucket name. That's why we always have the convention of using a bucket prefix as a mobile number. So it will always end up in a unique bucket across the global AWS bucket namespaces. So that's why when you create a bucket, bucket is it must be unique across the AWS cloud infrastructure. So that's why I'm prefixing mobile number here. So I'm going to give SloopStash support number. Okay, this is our support number 782480047, and then I'm going to hit enter. Now, when you press the enter, it will try to show something in the output. Now, you will be able to see something is happening in the terminal. What it is trying to imply is basically like it is saying that this is the blueprint. Okay, this is the blueprint, or you can call it like a plan. Okay, so it says that this resource will be created. So it says Kubernetes subnet 2 will be created. It says that this NAT security group will be created. It says that load balancer security group will be created. So you see so many resources will be created. It's trying to imply an information here saying plus means it's going to create it newly. Okay, you get the point, right? So whenever you run a plan command, always you will find some kind of a blueprint being printed on the screen. Okay, this is not a UI screen, this is a text-based terminal emulation. So you see here, finally you will get an statement like say 28 to add. 28 means it is going to altogether, it is going to create 28 resources in the reality. Okay, reality means AWS cloud is the reality here. Okay, so we are dealing with the reality cloud and we are dealing with the logical infrastructure definition here. So we should know what is logical and what is a reality. Okay, so in the reality, we are going to create 28 resources on AWS cloud and 0 to change and 0 to destroy. And it will output our NAT servers public IP. We'll use that as SSH Bastion host and we'll have a chef bucket. Okay, so where we'll upload the cookbook S3 bucket. So now you can see it is also saying the plan is now saved to conf prd tf plan. I'll show that here. I'll try to hit tree command. You can see this plan file is newly created now. Okay, which we didn't create, and you can also see this Terraform state directory is created, and these things we didn't create. Terraform will do that. So if you open this plan and if you want to read that, it's a binary blob. You can't read it, compressed one. Okay, now I'm going to execute this plan now. This is the plan. This is output. Whatever you are seeing in this blueprint is now available in this saved file, and this is the file. And we are going to now apply this plan to create the resources in the reality infrastructure. Okay, that is the AWS cloud here in our case. Okay, AWS cloud. If you want to do it in Azure or parallel in AWS and Azure, you can do that. So this is what we are going to do now. Okay, now let me go back to the workshop document. And you see apply Terraform plan. In the Terraform plan, I'm going to use this plan template. Now let me execute it. So it will show an output like create complete like that, but we have to wait for another 20 or 30 seconds for it to complete the Terraform run. It is now creating the resources, and we have the we use SSO based login for our for our training account. This is our training account. We use it for training purposes and demoing purposes for these kinds of workshops and all that. As a company, we use Amazon's what we call it as organizations and SSOs. Okay, so that's what we use to try and log in a single sign-on for all the users here. So we manage multiple AWS accounts, so that's why we do it like this. So you can see here, this is the AWS login page. Dashboard page where you log in. Now you can see the Terraform run is completed. So it's saying the apply is complete, and you can see in the reality, you will be able to see 28 resources added. I'm not going to sit and run through all the 28 resources, but I'll just show what we have done, what Terraform has done. And it is also given an output for, it created a bucket, so it gave the bucket output. So you need to copy this output and paste it somewhere here. This is useful down the lane. Okay. Now I'll just do some simple verification on the reality in AWS, what has happened. Okay, first I'll start from IAM. Okay, in IAM, Terraform tries to create a role, okay, called PRD IAM EC2 role. You can see here in the configuration, the name will be like IAM EC2 role or PRD IAM EC2 role. That's the name. So I'll just go here into IAM role section and I click here. This is the IAM service. Sorry, not this one. IAM. So you can see IAM role is being created. Okay, so you can see the IAM role, EC2 role is created. Now, like that, now, once again, okay, fine. I think we didn't switch, Satyaraj, I think we didn't switch to the workspace. Do we need to switch?
You already in the broad
Terraform workspace list, right? Okay, we are in the broad workspace, fine. Okay, so we now have created that and you can see this resource is now created. Okay, so IAM resource, IAM EC2 role. Okay, and after that, if you want to check out the VPC resources, you can go to VPC. And in the VPC, you can click here and you should be able to see a new VPC called VPC net is created. You should be able to see it here. Okay, I'll show it here. So you will be able to see, let me clear this one. So you should be able to see VPC net. And you will also be able to see some subnets being created for Kubernetes, which is VPC load balancer, subnet, load balancer, 1, 2, NAT subnets like that. So you will be able to see the subnets, all these things, and you will be able to see the route tables, the public and private route table. So these are all the resources that is automatically added into the Terraform template. Okay, and I mean, these are all the resources that is automatically added into the AWS cloud as a result of this Terraform run. So when you use this, you will be able to see outputs like this. Once again, so this I'll just scroll from the beginning. When you run this plan, you will get an output like this. And once you complete this plan, what you will be able to see is, after the execution, you will be able to get an output like this when you apply the plan, and the creation is complete means you will be able to see the resources created in the reality. Okay, now this is the important thing we have to understand. So now the resources are here. I also verify the S3 resource. I'll go to the S3 bucket and S3 service and show that a new bucket is now created. That is this one, 7824 prod S3 OSW chef bucket. So you can see where we will be uploading the chef cookbook. So all these things are now available. I'll also show OpsWorks resources like stack being created here in the OpsWorks. Go to OpsWorks stacks. So you should be able to see a stack called OSW Kubernetes stack is created, which has nothing running there. And also you can see some EC2 in the EC2 console. You will be able to see a NAT server popped up and it will run now. So you will be able to find that NAT server. Okay, the instance is running here. It's a NAT instance. Okay, EC2 NAT server 1. Which is the NAT server, which is very important component in VPC to allow outbound access to the Kubernetes nodes. Okay, so now we'll just understand all these things. We'll also verify whether the NAT server is properly placed in the private route table, because these are all required infrastructure setup in order to build the Kubernetes. I'll go to the route table and do the verification of the private route table, where you should see the NAT is attached. This is the NAT instance ANI. So all these things are supporting infrastructure. You don't have to know all these things by this time, but this is how you build the infrastructure required to run the Kubernetes. Now, once this plan is completed, we need to now move on to the next step, which is to do the Kubernetes cluster formation or the deployment. So to do that, first we need to upload the Chef cookbooks to Amazon S3 bucket we created here. Okay, so I'll use another, I'll probably use this other terminal here. Okay, do that. Let's see if it allows. So I'm zipping it and setting the F3 bucket name. I'll put it here. So what is the F3 bucket name? This is the bucket name, okay, which came as an output in Terraform template. Now I'm going to copy this one and I'm going to put it here. And then I'm going to upload it. We'll see whether it's okay. I think I have to do it in this place because this is the place where I have the credentials built. So I'll go to the Chef directory here and I'll upload it. Sorry, what I did wrong. Sorry. That's my bad. I have to put my S3 bucket name and then I have to run this command and we'll see if it is uploading properly. So you should see the move happened, and in the move you should be able to see the cookbooks, the Chef cookbooks were uploaded to the S3 bucket, which you can verify by going to the S3 service here. You can go to the S3 service and you can verify that. I mean, these are all the Kubernetes Chef cookbooks which you can find here in this bucket. Now you see cookbooks which is something which I've uploaded now. Okay. And so after uploading the Chef cookbook, what we have to do is we need to add EC2 instances to the OpsWorks layer. Okay, so I'm going to add my Kubernetes master node, Kubernetes worker node blueprints. Again, in OpsWorks, it is also called as blueprints here. Okay, I'll open it in a new console, other tab. So in OpsWorks, what the terminology that they use is they use something called as stacks. Under the stacks, you can have multiple layers. Under the layers, you can group your instances. So I have a layer for Kubernetes, which is called as Kubernetes 1 layer. Okay, so in that, I'm going to go and add instance blueprints. Basically, the static instance configuration, which is not a live one. Okay. Now let me go here. You can see I'm going to boot one Kubernetes master node, and I'm going to launch one Kubernetes worker node. Two worker nodes here. Okay. These are all the three blueprints which I'm going to form a tiny 3-node cluster only. Okay. So let me click the add instance here. Okay, so these things you can work out later on after the session is complete, once the document is with you. Okay, so I'm going to first put the master node here, and then I'm going to select the size of the instance. I'm not going to put a really big instance when wasting our money, so I'm going to put a T3A small. Okay, T3A small. This is the name of the EC2 instance. So OpsWorks will start instances in EC2. I'll show that in the EC2 console once the instance starts. Okay, so we should be able to see it here like this. Okay, in the instances dashboard in EC2. In the instances view, you will be able to see. Now, this is the host name, and this is the size, which is T3A small, and I'm going to select the Kubernetes subnet 2 thing, and you can see here VPC Kubernetes subnet 2. You can see the VPC subnet. I'm going to select it, VPC Kubernetes subnet 2, and EC2 key pair. The scaling type is 24/7 because we want it to run always. So we select EC2 key pair. And operating system is Amazon Linux 2, which is the one which we generally use and prefer to use in production infrastructures in AWS. So we use Amazon Linux 2 containers also. And inheriting from the stack, default settings, And other settings are simply EBS backed, and storage volume size is just 8 GB for root volume. And I don't have time to explain everything, but because it itself will take another half an hour to complete this process if everything goes well. Okay, so this is the master node, and T3 is small node, and subnet is Kubernetes SN2, and you see the key pair associated, which is Terraform has created that key pair in the Terraform run, which you can see here in the EC2, this one. And now I'm going to create a blueprint here. This is a blueprint in OpsWorks. This is not Terraform blueprint. So it looks like this. Okay, it's not the instance that is running live now, but it's just a configuration that you have added. And then I'm going to add a couple of worker nodes in Kubernetes. Okay. Now you see here the worker nodes are here. So this is EC2 instance for worker node 1. So I'll copy this one, the host name, and I'm going to again choose a T3A instance. T3A is small, and I'm going to give subnet as VPC SN1. Okay, VPC. Sorry, something went wrong. Okay, so VPC. Why it is showing so many other things? No, I'll just refresh here. So, one second, I'll refresh this one. So click here, add the worker node. Okay. The worker node, and paste it here, and T3A small. When you're creating this, we could have created this blueprint itself using Terraform, but the thing is, maybe when everything is automated, we can't demonstrate anything, so everything works just like that. So that's why we kept these parts as manual things. Okay, then we need to select the VPC SN1 Kubernetes subnet, and the EC2 key pair is this. And then we'll be using Amazon Linux 2 here, and then this is the configuration. So then add instance. Like that, I'm going to add one more instance. I'm not going to do more. So I'm going to add another worker node here. That is worker node 2. And so far, nothing happens. So no instance is running in the background. So we just create the blueprints. T3 is small, and Kubernetes SN1. Okay. VPC Kubernetes SN1, and EC2 key pair, and Amazon Linux 2, and add instance. Okay. So I think I have made it right. I'll verify once whether the subnets are proper. So you see the subnet is proper here. And because if I have a wrong subnet associated with the wrong one, man, there will be a problem. So you can see the subnets associated, and can see, yeah. So I think we have the proper subnets associated with this, and this is a part of that VPC. Okay. So, so that is how we have now created the resource blueprints here in the OpsWorks. Okay. So once the blueprint is created, what we are going to do is we are going to deploy the master Kubernetes node, and the master Kubernetes node, and we are going to boot up an EC2 machine by starting this this blueprint. When you start the blueprint in the layer, it will create an EC2 instance in the background, and what will happen is it will try to execute the chef recipes lined up in this layer. You see, in the layers settings, you can see these are all the recipes that will run up. Okay, the moment you start the machine blueprint, what will happen is an EC2 server will be started in the background, and you will be able to see these recipes getting executed there. Okay, so this is what is going to happen now. Okay, so those recipes are coming from the chef cookbook here. Okay, it's lined up properly. Now we'll go here and start the master one. Okay, so first we'll start the master, and we'll see how far it goes. Now we have some 2 or 3 minute time here, at least 2 minutes. So you guys can ask question on if you have any doubts in this place. Now, if you see here, the master is booted. In the EC2 console, you can go and see a new instance coming up, Kubernetes master 1, something like that with that name. You see, it's now running. You will be able to see that. So it's now booting. So we have to wait for another 2 minutes or something so that the master node, which is generally called as the, see, in the Kubernetes architecture, the master node is generally called as the control plane. Okay, so it's the control plane is what we are talking about. I'll go to the Kubernetes, this one. I'll show that Kubernetes. Where is the architecture diagram? This one. It's not loading. Okay. So you can see this is the Kubernetes standard architecture where you can have multiple masters. Here, this is the master HA setup, but generally it is called as control plane. And you can see the API server, scheduler, controller manager, etcd, core DNS. And here we don't run Docker daemon, we run containerd and CNI. All these things will run in the master or the control plane. And then we'll be able to run the workers where you will see the kubelet and the kubeproxy will be running. Okay, so this is a generic architecture of Kubernetes, and that's what we are trying to. We're trying to form a cluster like this, much similar cluster in this ops workspace. Okay, so you can now see the running setup is happening. We have to wait for some time. Before that, I will try to SSH to this master node and show whether things are happening or not, but because first we need to verify that. So let me go to the workshop document and I'll first, so now we are here, we are trying to deploy the master node. We'll now go and SSH to the master node via the NAT instance and see whether that something is happening or not. I'll use another terminal here. Okay. I'll use this terminal to do this part, clear this, okay, and I'll SSH to this, and I'll form this SSH command here. To SSH, first you need to SSH to the SSH bastion. Here we use NAT instance as the SSH bastion. So it's like a jump host, okay, and then I should be able to SSH to the master Kubernetes node. Okay, the IPs are not static, so we have to copy paste the IP from the OpsWorks UI. Okay, so here I click, you can get the private IP, copy this one and put it here. So this is your Kubernetes control plane or the master. We have only one master node, so this is the Kubernetes master node. Okay, and then we have to form the worker nodes also. Kubernetes worker 1, this is master 1, and then the worker 1, and then we'll form the commands for worker, because we'll be, once we run the Kafka workload, we'll be able to see that by SSHing only. Okay, we are not going to expose this cluster to the internet, it's a private cluster. Okay, so this is the NAT or SS, you can call it like SSH bastion host. Okay, now we'll see what's happening if anything happened. Now you can see the machine master came to online. Now we'll do some quick verification process. Okay, so first my agenda today is that before break, okay, before we'll have a break, we'll try to at least complete up to the Kubernetes cluster formation. After the break, we'll try to run the Kafka workload and see what's happening. Okay, so I'll try to take not more than 20 minutes to complete it. We'll see how far it goes. Now let me first SSH to the NAT, okay, or bastion host, and then I'll SSH to the Kubernetes master. Okay, from the NAT, and I'll show if we'll see if things are working fine. Now you can see this is an EC2 instance managed by OpsWorks. That's why you see once you log in, you will get these kinds of banners and all that customized things. Okay, now this is fully managed using Chef configuration management deployment engine. Now I was able to get into the master node, and I'll use this kubectl command to check and see whether the master node bootstrapped successfully. Now you see when I'll clear the screen and show. When you see here kubectl get nodes, you can see the master node is now status ready and it's called as the control plane, which is generally we call as master. And the version is we use the very latest Kubernetes, which is 1.24. So far, even in our training program, we so far haven't revealed 1.24. We still in 1.19. How we prepared this for the workshop. And this is the internal IP, and this operating system is the Amazon Linux 2, and the Linux kernel version is 4.4, and the container runtime which we've been using is the container D. Generally, we tried it with Docker, CRI, but the problem is so far the CRI is not matured with Docker. Kubernetes is trying to decouple Docker from, because by default Kubernetes plugs with the Docker from the very beginning. For years, Kubernetes have been bringing the give first support to Docker container runtime. Now they are trying to reduce things by making containerd, which is another byproduct of Docker company. Okay, so that's the OCI runtime which you can see here, container runtime. So because Kubernetes is in the Kubernetes session, I generally talk about understanding Kubernetes as a framework, because Kubernetes works with different container network interfaces. Kubernetes works with different container runtimes like this, Docker, directly Docker via Docker containerd, or directly containerd, CRI or Rocket. Rocket support is deprecated. So you see, Kubernetes is a framework, it's an orchestration engine, a container orchestration engine. We call it as another extra word. It's a framework where we can plug and play with the different container runtimes, different container networking interfaces, and you can build your own customized cluster. Okay, so that's the use of it. Now, coming back to the thing here, once you see things happening like this, you can also verify the Kubernetes API control, API scheduler, all that things. You can see that by running sudo CRI CTL PS. You will be able to see the core DNS, the flannel network is powered up, the API server, scheduler, etcd, controller manager. All these parts required to build a minimalistic control plane, or we call it as control plane components, is now up and running. Okay, now you can ask me who did all these things. Okay, in the Chef directory in the Kubernetes, you see a Chef cookbook. In the Chef cookbook, you will be able to see the Kubernetes cookbook and Docker cookbook and other operating system cookbooks. You can see this is how Kubernetes is built. This is a Chef recipe. Okay, this is a Chef recipe. This Chef recipe has built this cluster and formed the cluster. Built this master. So far we didn't do the cluster formation. We have just built this cluster, and this is called as resources in Chef, which helps you to you can very clearly see, for example, initializing the cluster, configuring, creating a flannel network, and enabling the pods and all that. So you can see it is a very powerful tool to do a cutting edge deployment automation in any kind of, whether it is a container or a virtual machine or a server. You can do cutting edge automation in a very simplistic way. You don't need to be a big programmer to actually learn this. It's a very simple thing. Okay, copy pasting the blocks and customizing. Like that, you can see we run the Docker related things, which brings containerd, where you can see the setup here. And you can also see system cookbooks where we'll run system level services. So altogether, this is how we are building the Kubernetes nodes, okay, which I explained in my this whiteboard. So now we are in the second step. So we are trying to do the formation of the cluster. So we have now built the master nodes. Now we should be able to build the worker nodes in the Kubernetes. Okay. So Chef has done the deployment here of the Kubernetes master plane, control plane components. So you see as a result of that, these services are running as Kubernetes parts. Second, we now need to bring up our worker nodes, because worker nodes is the place where we are going to run the Kafka cluster. Okay, so we are not going to use the master. We don't schedule any kind of a container workload in the master node. Okay, we have to use the worker nodes to schedule our workload. So we're going to start the worker node now. So before starting the worker node, we need to create something called as a cluster token, because without the token, a worker node can't join the master node. Okay, now to create the token, you can use this command. Okay, so I'm going to run this command in the master node very clearly. You see here, this will show you a command with a token referencing a token and a token hash. These data is an important data to form the cluster. It's an authentication or an authorization credential in order that so that the worker node can connect with the master node and form a cluster. Okay, so I'm going to take this command and I'm going to strip out, or else I'll just take this token. So, okay, I'll take this token and I'll put it in my here. Okay, Kubernetes. It's called as bootstrapping token. Kubernetes bootstrap. I just keep it token, and this is the token, and there is something called as a token hash. This is the token, and the other one that you see here is the token hash. Okay, Kubernetes token hash. Okay, the token hash is something which looks like this. After that, okay, so you just copy that and put it here. We could have automated even these things also, but we don't do over automation, because if we do everything automated, then I have nothing to speak in the session. Everything will run automatically, so I can't show anything here. So, so these are all things which we have to do manually to engage people. Okay, now you see these tokens that you have, we need to put that into the layer configuration. So we need to add the Kubernetes token to the OpSource layer, so that when you start this worker nodes, it will be able to get the token from the layer settings and it will be able to join the cluster. Otherwise, you won't be, the worker node will run, but it won't be able to join the cluster. Okay, now what I'm going to do is, I'm going to take this snippet. Okay, I'm going to replace the snippet with the data here. Okay, so Kubernetes token. Okay, this is the Kubernetes token, and Kubernetes token hash. I'm going to take it and I'm going to put it here. Okay, and you also need to give the master nodes private IP, because when the worker nodes are getting started, what it will try to do is Chef will try to, I'll show the part here. When when the worker nodes are trying to start, what will happen is it will try to execute this kubeadm join command. In that, the token will be supplied and it needs the master IP address to join properly. Okay, so otherwise it won't properly join. Okay, so we need to give the master IP. What is the master IP? The master IP is this one. Okay, which master's private IP. So I'm going to take this one and replace it carefully. When we try all these things, we have to be a bit careful in copy pasting without any spaces, because when you have copy pasting with the spaces and unnecessary things, you will have trouble in the cluster formation. Okay, now I'm going to copy this JSON string and I'm going to add it to the layer settings here. You see this layer, or OpSource Kubernetes layer. Here, I'm going to go to the general settings. You can see this is now null, and I'm going to edit it. I'm going to save it. Okay, so I'm going to put it, this is the token, and this is the token hash, and this is the master's IP. So all these things I have properly saved here. Okay, so once you've done that, save this. So it will look like this. Okay, after this only, you have to go and boot the worker nodes or deploy the worker nodes. Okay, so deploying of the worker nodes, again, simple. You just click start. Okay, and you can parallelly start as much amount of worker nodes, 4 or 5 or 10, whatever you want. So I'm going to again start this as well. We'll see how it is going to run. So now in the first terminal, you can see the Terraform level stuff. In my second terminal, I have the Kubernetes master SSH to the master node. Now I'm going to take SSH to the Kubernetes worker node 1 and worker node 2 in the other terminals. Okay, because for verification purposes. But that has to boot, so we have to wait. Anyone have questions so far with this? Anyone able to understand what we are trying to do? I mean, people who are who have newly joined also, that's fine. You can ask your questions. You can unmute and ask, because anyway this is a small leisure time that we have, because it takes some time to boot. We'll see. How many of you are able to get what we are trying to do? Is that understandable?
Yes, little bit somewhat.
Okay.
Yes,
One
John.
question, John.
Okay. I think people from both the groups can ask. So you can ask a question. I'll repeat the question because 2 meetings are going on. So people from this group may not be able to see what's happening in other group. Okay.
No, is AWS ops work is same as RODGEF or it would
is
be
a
a little bit different?
It will have a Jeff client. I mean, what one person from the other group is asking is Dinesh Balraman, his name is. He is asking whether the AWS OpsWorks is RODGEF or else it is a kind of another component. So it is a managed service. So what you can get in the AWS OpsWorks is you will be able to see the Chef client being built into it. Okay, you don't need to install the Chef client, because when you go with a typical Chef architecture, you will be able to see components like, for example, you will be able to see components like the Chef workstation, the Chef automate or infra server. So you have to deal with lots of Chef components. Okay, this is a typical Chef architecture, totally coming with all the Chef components. But here we don't use this complete architecture. What OpsWorks actually does is it will just try to deploy the Chef infra client or the Chef client in the EC2 instances like this, and OpsWorks takes care of managing the whole data related stuff and supplying the essential needs. So they have the Chef infra server internally managed by them. So that's not exposed. So you don't need to go and manage this component like Chef infra server or automate like that. Okay. And Chef client is also baked into the instances that you are running here. So that is how it is. Okay. Very powerful service.
So if in case we are building the same thing on VMware environment, then we have to learn Chef also, right? The work done by Ops Center.
Yeah.
Okay.
So even if you use a VMware infrastructure or building VMs and all that, you will be able to do that using Chef. Okay.
Okay.
Right. Now I think both the nodes came online in a matter of 2 minutes or 3 minutes. So you can see both the worker nodes have come online. We'll now go here and check in the master node whether the cluster formation is done or not. Now we'll click. Now I'll clear that. And you see Kubernetes list nodes command. You will be able to see that the nodes are saying ready status, ready status. This is the worker node 1 and this is the worker node 2. So you are now able to see the master already ready. It's called the control plane role, and worker is now ready. And you can see it's all the same kernel, same container run times and all that. I can also take the SSH to the worker node and I'll show how it actually looks inside. Okay, we'll do some small verifications in what is running, and then we'll take a small break, and then after that we'll go and run the Kafka workload, or else we'll see if we can do it and completely have a QA time after that. I'll check and see the timing. So this is the worker node 1 SSH, and this is the worker node 2 SSH. SSH EC2 user at this one. Okay, so I'll try to SSH to the worker node 1 now in this terminal. Okay, and this is the worker node 1. And this is the worker node 2. Sorry, here. Copy, and here. And this is the worker node 2. Okay, so you can see in the worker nodes, the workloads that run here is CRI, CTL, PS. You will be able to see the kubeflannel and the proxy is running. In this worker node also, you should be able to see similar things, sudo CRI, CTL, PS. So you can see flannel and these parts are running, proxy parts. Okay, so these are all the things that will generally run in a minimal worker node. So now, according to our plan, the cluster formation is done. Okay, according to our plan, we have now deployed the worker node, and we have deployed the master node, and then we have deployed the worker nodes, and all these things are built using Chef internally. Okay, deployed using Chef. And the cluster formation is done. Without the formation of the cluster, if the cluster formation has not happened properly, you won't see the node state. You won't be able to even list it here with the kubectl command from the master node. Okay. Now the thing is, we have to prepare the environment for Kafka. Okay, we have to prepare the environment for Kafka. For that, we will be running a simple Chef recipe that will create some directories required for running the maybe it operates as a volume for Kafka nodes. Okay, so to do that, I'm going to execute this recipe, Chef recipe, and from my. Before you do something, you have to always check the workload. You see the system load, it is 0.22, here it is 0.09, because when you are having a T3A small instance which comes with just 2 GB of RAM, sometimes you may get blocked with recipe execution, so because it's a small instance. Okay, now I'll run this command. Run the Chef recipe, execute recipe to configure the Kafka environments, are basically the Kubernetes volumes that is needed. Okay, so you see this is the recipe, a cookbook, and this is the recipe name which I'm calling on all the instances. Execute recipe. Okay, on all the instances, and what it will try to do is I'll show that recipe what it is going to do. It will try to create the volume Kubernetes persistent volume directories. Okay, basically AWS has in Kubernetes it has an integration with AWS EBS, so that it will be able to create the EBS volumes on fly. But it was deprecated some time back, so we went to use a simple local directory based volumes. Okay, so that's what it is going to do here, and it will deploy the starter kit Kafka starter kit into all the nodes. Okay, so that's what will happen. So we have to now wait for it. So I think this is a pretty lengthy workout, I know that, but this is one of the things which is most frequently asked by people. So most of the people, from our community generally asks whether is there any place where you run Kafka kind of workload in Kubernetes and all. So that's why we have prepared things like this. Generally, we can take this session for 4 hours. Okay, so if last time when we are planning Kubernetes, Hadoop on Kubernetes, we did it for 4 hours actually, 3 hours actually. And after that, we had a Q&A session. Now this is done, so we can go with now the running of the Kafka cluster. Okay, so we don't need to take a break. This will take another 5 to 10 minutes to do that. We'll complete it and then we'll see. Okay. Okay. You see, I'm going to go into the master node and I'm going to add some labels to the master node, because when you go to any typical cloud infrastructures, we need to tell Kubernetes to understand the underlying infrastructure by adding something called as labels. Okay. Here, where these labels are going to be used is, you can see here that labels are used for setting the node affinity when you run pods in Kubernetes. Okay, so the labels will, when you run a stateful set or a pod in Kubernetes, it will be able to hang on to that worker node by using these labels. Okay, so that's how you map the proper pods or stateful sets to the particular worker nodes. Okay, so you can see we use a bunch of labels here. We define a bunch of labels like type equal to cloud, provider, custom labels. Provider is AWS, service is EC2, region US West, availability zone is US West 2B. Like that, we label the worker node, the master node, and the other worker. So all those nodes we have to first start with labeling. Okay, so now I'll first do the labeling part. So all these commands we have to run from the master node only, otherwise it won't work. And now I'm setting it for the worker node and labeling the other worker node. Okay. And then I'm going to switch to the Kafka starter kit directory in the master node in Kubernetes, where you can ask me how this Kafka starter kit directory was deployed. So that was deployed as a result of this chef recipe run, which I showed some time back. As a result of this chef recipe run, which we did some time back here. So this pulls the Kafka starter kit from GitHub. Okay. You can see the Kafka templates here, Kubernetes templates, you can find it here. So this is what is downloaded, and now it will be deployed into the master nodes and the worker nodes. So we'll first now go to the Kafka's starter kit, and we'll then we'll first create something called as volumes, which is needed for storage of the data in Kafka cluster. Whether the controller or broker, both these things have to store the data. So first I'm going to run that persistent volume. So you can see I'm trying to run a 3 controller, it's called quorum controller. So we're going to run 3 quorum controllers, and we're going to run 3 brokers in Kafka. Okay, I didn't talk more about the Kafka architecture and all that because time is also a constraint here. Okay, now then we are going to create a Kubernetes namespace called staging, where we are going to isolate the resources. The namespace like in Terraform, we have a namespace. Like Terraform in Kubernetes also we have namespacing, which is generally called as Kubernetes namespaces. Okay, Kubernetes namespaces are an isolation. Okay, I'll just use this slide. The Kubernetes namespaces are an isolation. You can basically have multiple environments like staging, pre-staging, and everything. You can isolate your resources based on a simple namespacing there. Okay, so suppose you have built a set of Kubernetes resources from under one namespace and another namespace. Both these things don't have an interconnection, so there is no interconnection between these things. So it's all isolated. So that's how you can isolate the resources based on environment name. Okay, so here we are going to create that namespace as staging. We can create prod, staging, whatever it is. I am just going to create staging. And then I'm going to create some configurations. See, when you run a Kafka cluster, you need to load these configurations of the broker and the controller configurations into the Kubernetes cluster. Then only when you schedule the parts of Kafka, it will be able to get the configurations. You see the configurations here, right? These configurations, Kubernetes must understand it. So that's why we create something called as config map. So first we'll start with setting the cluster ID, and then we will create the Kafka controllers configuration that is required to run the Kafka controller parts. And then we will create the Kafka broker level configuration. So it will run the broker level parts. Okay, required for broker level parts. So once you do that, there is a simple summary command in Kubernetes. You can see what are all the resources being created. So I'll clear this one and show this. You can see now so far we have created persistent volumes for Kafka controllers and brokers, and you can see it here. And we have created a namespace called staging, and then we have created config maps for the broker, Kafka cluster, and Kafka controllers. Okay, this is a proceduralistic way of running that Kafka workload in Kubernetes. Now, after that, we have to create the Kubernetes service. As I said, in Kubernetes, it's an abstraction. So you have to define the broker as well as the Kubernetes, you have to define the broker as well as the controller as services. Now, you can find this configurations here, all the Kubernetes related configurations under the Kafka starter kit. So the persistent volume templates here. I can't explain all these things in detail. It takes lots of time, but I'm just showing this. This is Kafka controller service abstraction, and this is the Kafka broker service abstraction. And this is the stateful set for Kafka broker, where it will start the containers, and these are all the container configurations you see here. Okay, how the configurations are loaded and how the volumes are attached to the pods. And this is the broker stateful set. So, I mean, explaining these simple things will take more time, but you can verify all these things when you have some time. Okay. Now, let me go to the execution. Now, we'll create the service. So Kubernetes service, and you should be able to see two services being, every time when you create some resource in Kubernetes, you will be able to, you can hit this summary command and you can see what's happening here. Now you can see a service called broker and service called controller is created, and it listens on the port 1982 and 83. Okay, and then now we are going to launch the stateful set. When you launch the Kubernetes controller parts first, Kafka controller parts first, what will happen is that you have to wait for some time and check and see whether the load is going high or not in the system, because you are using a T3 small instance, okay, T3 small 2 GB of RAM. So you have to wait for some time. So now let me take the controller and I'll show and I'll execute, and we'll see what is happening. So you can see the controller nodes are created. I think the name is controller node, but it will create 3 controller nodes. So I'll now hit this command. So you see here, you can see a new pod is now getting created and the status is now container creating. Okay, like that you will see 3 controller nodes coming up, or 3 pods for Kafka controller will come up to make it highly available, because when you build a Kafka cluster, you have to at least go with 3 controller pods in order to satisfy this K-Raft. It's a kind of a Raft consensus algorithm built into it. So you see container creation is happening. You can run this command again. So you can see 1 container is running, and we have to wait for the other containers to be provisioned. The reason why it is taking some time is because it will try to download the Kafka image from the Docker Hub. we have uploaded this Kafka image in, we have built this Kafka OC image using Docker tools, and then we have uploaded it to SloopStash namespace. So it is getting downloaded from the Docker Hub, the image, Kafka image. So without the image, you can't run the container. So that's why it is taking some more time to do that. Okay, so we have to wait for some time. So we have to check again and see. Now we can see in worker node 1, we see one controller, Kafka controller is scheduled. And in the worker node 2, we see one controller node is scheduled. Because of the download thing, it will take some time. So we have to generously wait for that. Okay, after the first download of the image, it will happen very fast. So now you can see the third controller node coming up, and we have to wait for that. If you can check the worker nodes by running sudo cri-ctl images command, you will find docker.io SloopStash Kafka image, which we have in the Docker Hub, is downloaded. It takes some time. You see, it's a pretty heavy component with built-in JVM and all that. So it's a bulky image. So you will be able to see it here. And even here also you can see CRI-CTL status and find Kafka image downloaded. So that's why it took some time to start the container. Otherwise, it will be very fast. Okay. Now let me check and see. Now we have. So you should see ready one by one, which means out of one container is running. You can also configure multi-containers in a single pod. That's different. We didn't do it that way. So you can see the Kafka nodes, controller nodes coming up. And after the controller nodes coming up, what we have to do is we have to check the load of the machines. You see the load didn't spike out in worker node 1 and the load didn't spike out in worker node 2. Okay. Now we are safe to go and run the broker deployment. Okay. So again, it is also a stateful set. We have tweaked the JVM to use 256 MB of heap. So I will now go and run this one. Okay. So now when you apply the broker, when you execute the broker provisioning, you should also see the same kind of an output here in the command. So you can see the first broker node is getting started. It will roll out slowly one by one. Okay, it will not do everything in a single flash. It will happen one by one. So we have to wait for some time for it to provision. Because these are all tiny instances, not a big instance for Kubernetes to do something in a very fast way. So we have to wait and see. Okay. Second broker is coming. Like this, you can run multiple brokers. See, the point here is it's not just a 3-node Kubernetes cluster, not just a 6-node Kafka cluster. You can build 100-node Kafka cluster and in a 50-node Kubernetes cluster, just exactly the same way. But the size is what is different. That's all. Same procedure, same things. You can try and let us know what how it works. So this is how it has to happen. So you can see the final broker node is coming up, and you can, okay, no, I think it should be ready. So you can see all the workloads, the Kafka broker workloads and the Kafka controller workloads, all those workloads are now actually properly scheduled to the worker nodes based on the node affinity and now running. So now you see that it is running. Now we need to verify things at the Kafka level. Okay, this is Kubernetes level. We have seen the workloads running here like this. We have made it. Now we have to see from the Kafka level, see whether really the cluster is formed in Kafka, or whether the controller nodes communicate with each other, or whether the broker nodes are properly merged with the controller node. So all those things we have to check now and slightly publish a message and see whether it is receivable or not. So like these things, we'll first do the verification. Now, to do the verification, we can just take the bash shell of the Kafka node. You can see I'm going to take the controller nodes. You can take any controller's bash shell. This is a simple kubectl command. Okay. I'm going to give the name of the Kafka controller node and the name of the container and invoke the bash shell. Okay. So this is, now we are within the container. So here we are in the container, and I'll show how the Kafka node is running. You can see a Java JVM process. This is the Kafka controller node. Okay, 0. So the JVM, you can see this is how it starts, and we use the simple shell script to trigger the, and we also always trigger the Kafka scripts. We don't write things on our own, and we use supervisor CTL always to maintain the processes within the container. You can see it is now much more manageable. You can do restart, start, stop, all those process management cycle is very easy if you use supervisor, okay, within the containers. Now this is the container. Within the container, Kafka controller container, node number 0, or I think it's called 1 now within the Kafka. And I'm going to run some simple commands in the Kafka to show that the cluster is formed. Okay, so I'm going to access the Kafka's meta shell, and I'll show, this is the controller node. You can access the node number 1 or 2, whatever controller node. You will see, you should probably get the same information. Okay. Now I'll show that by running few commands. You can see the brokers are registered. That's why it's showing brokers directory here. Else it don't show the brokers directory. Now I'll show the brokers registration IDs. This is the registration ID of the broker. And you can see this is the broker node 0. You can see this is the pod name actually. And this is the service name. You can find it here. I don't have time to explain everything. When you do it, you will be able to get it. Okay, so I'm showing the another broker, 1001, and you can see the other broker. So totally we have 3 brokers in place. So you can see that. And I'll also show the leader of this. I mean, we have 3 controllers. So which controller is the leader controller? You can see the leader controller is the 1, which means this one, this controller node 0 is the leader of the quorum controllers. Okay, so maybe those who know Kafka may be able to get the point which I'm saying, but otherwise also it's fine. Now this is the, you can access the same in node 1, node 2, whatever pods you wanted to connect. And now I'm going to exit this one and I'm going to do some simple small workout. Okay, we can't do more because the time is getting over. I'll go to the another Kafka broker node, and we'll try to do some message. Sorry, I have to come out of this one. Okay, so here, and now I'll go to the connect to one of the worker node shell. Okay, sorry, broker node, and then I'll try to create a topic in Kafka. Say basically say activity tracking or streaming or something, and I will try to give partition number as 3 and replica factor as 2. So it's all just using the Kafka's provided command line tools. Okay, they have provided that. So we're going to create a topic called activity tracking. Now the topic will be created, so you will get an output called activity tracking. Remember when someone asked a question sometime back, I said you can create something like a topic and push data to that, and it will be taken by the subscribers of that topic. It is one of the important use case pub/sub mechanisms of Kafka. Okay, and you should be able to see the what we will now go to the Kafka producer console, and I will be giving some messages here. Okay, using the producer console. Now. Let's say I'll say this is my first message, and then this is my second message. Okay, so I've given a couple of messages, put a couple of messages under this topic, and now I just wanted to exit out of it. Okay, so I'll just exit out. Control D, right? Control C. You totally exited. Okay. Now I'll open the consumer. Okay. So let's see whether the consumer is able to print out the messages which I have put in the topic. Okay. So it's simple workout. Okay. So you should be able to see it is why it is I think exit also is one message. Okay, so I unknowingly create that. So you see, we created a topic and we added a message, pushed the message to the topic. Now, when you subscribe or consume that message or listen to that message from that topic, you will be able to see it is broadcasting those things here. Okay, so I mean, this is a simple thing what we have done. This is how we have built the Kafka cluster. Okay, and this is how we have been able to do that. Actually, we don't do it like this. We need to use a Python client or a Java client or something like that. We don't use shell scripts to do that. So we connect with the Kafka brokers and we will be pushing the messages and getting the messages using programs. Okay, this is just for demonstration purpose. We did it like this. Okay. I think now I have completely demonstrated how many of you are able to now understand. So you can now ask the question regarding the cluster formation. I should be able to answer. I think I kept my time. I didn't cross the 7:30 mark. Okay, so you guys can open up and ask the question. Is that topic interesting or a lengthy one, or you can give your honest feedback here. We can collect it and come up with a better workshop next time.
So I have a doubt. So basically, if any one of the Kafka node goes down, will Kubernetes automatically provision, or that is a separate thing that has to be done?
If the node goes down, Kubernetes will be able to maintain that state. Okay, it will try to do genuinely, I think 3 restarts or 3 times it will try to rejuvenate itself. If after that attempts it fails, it will be gone.
Okay.
Okay, so because whatever, whether in Kubernetes or a Swarm cluster, whatever container cluster platform you take, it will try to do some kind of a self-healing or rejuvenation by itself. If some pod goes down, it will try to bring things up. But if that is not going to happen after 3 or 4 attempts, it will try to say it is totally out of scope or it is down like that.
And one node not necessarily to have one Kafka, right? Within a single VM, we can have multiple Kafka.
Yeah, that is how you see here in this setup. That's why people have to raise the questions. You see, I'll show the sudo CRHETLPS. You see, we have 2 controllers scheduled in this worker node 1 VM. This is a VM. In EC2 instance is internally a virtual machine. Okay. So you see Kafka controller node 1 and 2 in worker node 1, and the broker node 1 is also scheduled in the worker node 1. If you go to the worker node 2, you can see the broker 2 broker nodes are scheduled in the worker node 2, and you can see 1 controller node scheduled here. If you have more Kubernetes nodes, it will be more distributive. Now we have only 2 worker nodes, so it has to distribute or share between that. Okay.
Yeah.
So kindly give your feedback in the WhatsApp chat. So because in the Google chat, everything will evaporate after the session is over. If you have any comments, you can. Your Hadoop workshop is done. That is already posted in SloopStash blog. You can get there. Ramu Naga. Get it there. Any questions? So I think I have kept my time and slightly a bit faster, but there is no other way. It's a big workout actually. We can still do more verifications and things. Okay. Demolishing the thing also is very simple. You have to delete the Kubernetes namespace and delete the volumes and delete the Terraform workspace. That's all. It will demolish the entire infrastructure. Anyone have questions? Please let us know. What do you feel about, is it possible to increase kube replica after pod deployment? Yes, Damodaran, you can do that. You can do that. We don't have Kubernetes dashboard being built here. Okay, we have only the command line Kubernetes tools to show the nodes listing and all that. If we have, I think this is the trademark kubectl program, which we used to see the nodes and all that. But there is something called as a Kubernetes dashboard, which helps you to see things in the UI. At the moment, we didn't include that because, again, adding lots of components will try to bring so much amount of time. We need more time to do all that. Okay, with the Kubernetes dashboard, we should be able to do this. Okay.
How many EC2 now deployed totally?
Now totally we have 3 EC2 instances deployed under OpsWorks. You see master 1, worker 1, worker 2. That's which you can see in
Each container have the separate EC2 instance or how?
No. In a single EC2 instance, you see worker VM1. This is the EC2 instance. Okay. In that you see 1, 2, 3 containers of Kafka is scheduled. Apart from that, we have some Kubernetes level containers also running. Pods. If this is worker node 2. Okay. Here you see 3 Kafka level controllers running. Apart from that, you see Kubernetes pods also running. Okay. So in a single VM, you can run multiple containers.
Okay. Thanks.
Okay.
Is there any diagram? Workshop diagram for the diagram, how you deployed EC2 on the container, where it's.
Diagram, we don't have a diagram. I mean, maybe when we come with a blog post, actually, we will have some diagram like this, like this. We'll have some diagram like this when we complete the post, but that will take another 1 week to do.
Okay.
For now, if you, I'll be sharing this whiteboard. I'll be sharing this whiteboard with everyone. And I'll also share this workout in the WhatsApp group. So people can, who are willing, because whatever I did is completely from this document only. So anyone can try it. Yes, you will be, if you stay in that WhatsApp group, you will be able to get the updates for future workshops and training programs and many other things. We'll be converting the WhatsApp group into a community group by tomorrow. Okay, and we'll be pushing job updates as well. Any questions you guys have? We didn't actually have a break today because I also know there is an India-Pakistan match today, 7:30. So, so when we put people on hold, people won't be seeing this. So that's why we just completed the hands-on. We can have question answer time now. Anyone having issues, questions, please ask. Sure, Bala.
Thanks, John. The session is nicely conducted. I like the wide dashboards and all. That was pretty good.
Okay, thank you. Kindly put your feedback in the WhatsApp group. So, because that will be recorded somewhere. But when you put the feedback in the Google Meet chat, it will, after closing, it will be gone. So others also will be able to do the workout after this, because we'll be putting the document everything there. So we want people to try it out and let us know whether it is working for them or not.
So regarding this AWS account, so will there be an account that would be provided once we pay and join the class, or everyone wants their own account actually?
We will tell people to create their own accounts, and what we actually generally do in AWS sessions is we'll tell people to come up with new account. Okay, we'll tell how they have to create. All these things are documented generally, what tools required and all that, and then also we'll tell people to configure budgets. Okay, so these are all the preliminary things which we do in AWS session. So when a person creates an account, he has to first set the budgeting and alarms and all that. If it crosses $5 per month, they will be getting notified. Okay, and also what we do is whatever cost consuming resources. I mean, for example, if you go to VPC, there is something called as um, NAT gateway and elastic IP and all that. We'll tell this is a charge oriented resource. Okay, so but if you go to subnets, and all subnets are not charge oriented resource, AWS won't charge you for that. So people will tell at the end of the class, we'll tell people to delete these things, and next week we can, because 1 week it has to be there. So we'll tell them to delete in the same session itself. Okay, whatever it is cost oriented. So maybe fairly around less than 300 rupees is what they will get in all the 3 or 4 months of AWS sessions.
Okay.
So, John, you only cover the AWS DevOps sessions, or it's a combined by the multiple trainers?
No, me and my team will be there. I will be mostly doing the lecturing part, I mean the talking part, the whiteboarding and execution of the hands-on. And my team will be there in the support. Satiraj, Sujan will be there in the support generally. So they will be helping you with the issues parallelly when someone executes something and put chat, nothing, the command is failing or something. So they will be assisting you on that. I'll be doing the lecturing part and the whiteboarding and the hands-on part. I'll be leading that. So they will be helping in doing the support kind of roles. Generally, when last time when I was not available for a couple of weeks, Satiraj was handling the sessions. So in project sessions and all, they will be leading. So I'll be doing the supporting part. So that's how we share the workload. But generally, the lecturing part and the leading part of all the sessions, I will be doing. Okay. Project session only, people have to we split the workload for project sessions.
Okay, got it. I believe a new session is about to start, right, for a DevOps pretty soon?
Yeah, September 10th, we are going to start a new batch. Last batch completed yesterday only. So September 10th, we are kickstarting the new batch. We'll send the circulars in the community groups.
Okay, thank you.
What will be the duration of a batch, John?
The duration of the batch is basically like we have 9 months of scheduled duration, but last batch we touched 10 months. But generally we'll try to complete in 9 months. So it will be totally the Docker, Swarm, Kubernetes, Chef, Ansible, and AWS, Python, Ruby. So it will be a combination of all these tools. Okay. So we'll try to circulate this PDF after some time. So whoever interested can contact Basit or Sujan from our team. Dilip Kumar will share the information in the WhatsApp group, or else you can. Sujan, can you put the number or your number or Basit number in the chat? I think they can contact you. Someone called me now. I don't know who.
Yes, John.
Anyone having questions related to today's session? Susan, I think someone, I don't know, someone called me regarding the DevOps and all that. So I'll share your number. Please contact Susan or Basit. So I don't know, someone is shouting. Who is that? So, any questions? Please kindly put your feedbacks in WhatsApp group. Please don't put here because people don't know. Any questions? I think in case if there is no questions, I think you guys can drop the call.